You've seen Cosmos SDK chains from the outside. Now we'll step inside and actually build one piece. In this module, you'll implement a real custom module, wire it into the app, and make the chain do something it could never do before. To make all the abstractions concrete, we'll anchor this module around a single example, MsgSetProfile. You can think of it as a minimal production-style user profile service baked directly into a Cosmos SDK chain. Its job is straightforward. Accept a MsgSetProfile transaction, persist a structured profile keyed by account address, and expose clean query paths to read that state. We'll use this one module to practice real patterns, storage layout, message handling, and ABCI++ aware design. When you build with the Cosmos SDK, everything revolves around well-structured modules. A module is like a self-contained microservice for your chain. It owns its state, its messages, and its APIs. The keeper layer is your gateway to state and business logic, hiding raw storage details behind methods that enforce invariants and permissions. Types define the surface area, message types, parameters, and protobuf definitions that other modules and clients rely on. And the module entry point wires everything into the app, exposing CLI, gRPC, and routing. Getting this foundation right makes later ABCI++ customization much safer and easier. In Cosmos SDK, the keeper is your module's secure state engine. You can think of it as the only door into the KVStore for that module. The keeper owns the store key, the codec, and references to any other modules it depends on. All reads and writes to state should flow through keeper methods, never directly from handlers. This indirection gives you safety, testability, and clear boundaries between modules and their data. To plug a Cosmos SDK module into the wider application, you use two adapters, AppModuleBasic and AppModule. AppModuleBasic is stateless. It wires up codec registration, CLI commands, and gRPC routes. It describes what your module looks like from the outside without touching chain state. AppModule is stateful. It holds keeper references and participates in the full lifecycle: init genesis, export genesis, migrations, invariants. This is where your business logic is actually connected to the running chain. A solid module design keeps these two roles cleanly separated. App.go is where your blockchain actually comes alive. Think of it as the motherboard that all modules plug into. When you wire a new module, you follow a predictable pattern. First, you mount its KVStore keys so it gets its own slice of persistent state. Then you instantiate the keeper, injecting every dependency explicitly. Finally, you register the module in the module manager, so it participates in routing, lifecycle, and ABCI processing. In a Cosmos SDK app, messages are the front door for state changes. MsgSetProfile is simply a request saying, I want this profile to look like this. Its payload is just data: creator, name, and bio. There's no logic here, only intent. Before the handler can touch state, the SDK calls validateBasic. This is your first defensive line. Check required fields, length limits, formatting, maybe simple auth assumptions. Anything that fails here is rejected cheaply, before hitting the store or consuming serious gas. Well-designed messages plus strict validation give you predictable, safe state transitions and clearer invariants. When a transaction hits your module, it's really a request to a gRPC-style message server. The MsgServer method does three core things. First, it routes and validates. It checks basic fields, signer permissions, and any module-level invariants. Next, it executes business logic by calling the keeper, which mutates state in the underlying store in a controlled way. Finally, it emits deterministic events. Those events are how indexers, UIs, and off-chain services understand what actually happened. So MSG types define intent, MsgServers orchestrate, keepers change state, and events make everything observable. gRPC queries are how external clients safely read your chain state. You start by defining a query service in query.proto. Service methods plus request and response types. The generated interface is implemented by a query server in Go, which should only call read-only keeper methods and never mutate state. Then you register that server with the app's gRPC router using register services, so wallets, UIs, and other chains can query your module in a typed, efficient way. Cosmos SDK gives you REST for free through the gRPC gateway. You define your query services once in the protofiles, and the gateway automatically exposes matching HTTP and JSON endpoints. That means no separate controllers, routers, or manual marshalling logic. Also important, the old pattern of hand-rolled REST routes is deprecated. For new chains, treat gRPC plus gRPC gateway as your primary API surface. When you run a Cosmos SDK transaction from the CLI, a few things happen under the hood. The command you type is wired through getTextKMD, which maps flags and arguments into a concrete MsG, in our case, a MsgSetProfile. The keyring signs it, the client builds a TX, and it's broadcast to the node's RPC endpoint. The text hash you see is just the hash of that encoded transaction, which you'll later use to query its inclusion and execution result. Now let's see this in the context of our profiles module. The CLI hooks into the app through getQueryMD and exposes commands like show and list. When an operator runs query profile show Alice, the SDK builds a gRPC query, hits your module's keeper through the query server, and returns structured JSON. Automatic pagination means you can safely expose large datasets without manual page handling, and the JSON output is ready to be consumed by scripts, dashboards, or other services in your stack. Let's zoom out and look at how a chain state actually comes to life and evolves. At the very beginning, you have Genesis, a JSON snapshot that defines initial state and default parameters. That blob is parsed and injected into each module's keeper, so your app starts from a well-defined baseline. Later, for upgrades or migrations, you go in the opposite direction. You extract current state, serialize it, and use it as the starting point for the next version. You've now seen how to move from a bare scaffold to a working Cosmos SDK architecture. KVStores at the foundation, keepers as your state vault, messages and handlers as the public API, all wired into app.go. The next concrete step is to harden this with focused unit tests. From there, you're ready to layer on advanced ABCI++ hooks for proposal logic and vote-aware behavior.